here there is a network given. We need to find out the equivalent resistance of the network, and then also voltage drop. So first you take down the question. A network of resistors is connected to a 16 volt battery of internal resistance of 1 ohm as shown in the figure. Compute the equivalent resistance of the network. Compute the equivalent resistance of the network. Obtain the voltage drops VAB and VCD. Obtain the voltage drops VAB and VCD. VAB and VCD. First, let us see how the given network is. This is the given network. A 16 volt battery with internal resistance 1 ohm. This is the given network. Volt battery, 1 ohm, 4 ohm in parallel with 4 ohm, and then we have 1 ohm here, then again 12 ohm and 6 ohm. A, B, C, D. VAB and VCD we need to find out. That is the voltage. VAB is this voltage across terminals A and B, and then VCD is the voltage across terminals C and D. VAB and then VCD. First we need to find out compute the equivalent resistance of the network. So in this type of network we need to remember the thing, when we need to find out the equivalent resistance of complex network, first calculate the equivalent resistance of smaller parts. For example, here first you calculate the equivalent resistance of 4 ohm in parallel with 4 ohm. Then you calculate 12 ohm in parallel with 6 ohm. So we will get a series circuit. Let's see how it is. Four ohm and 4 ohm in parallel gives us, so we can write 4 ohm is in parallel with 4 ohm. and that gives rise to an equivalent resistance of 4 ohm and 4 ohm are in parallel. Therefore, RAB is equal to 4 into 4 divided by 4 plus 4, which is equal to 2 ohm. This is one part. Similarly, 12 ohm and 6 ohm are in parallel. 12 ohm and 6 ohm are in parallel. So RCD will be equal to RCD will be equal to 12 into 6 divided by 12 plus 6, which is equal to, do the calculation, 12 plus 6 is 18, so here 12 into 6 divided by 18. This comes to 4 ohm. So now redraw the network. Between A and B we have 2 ohm, 1 ohm, 4 ohm, and the battery along with series resistance will remain as it is. ABCD. So this is 16 volt, 1 ohm, 1 ohm, 2 ohm and 4 ohm. Now if we see this network, all resistors are connected in series. Therefore, equivalent resistance of the network is equivalent resistance of the network. All resistance in series, 2 plus 1 plus 4 plus 1 equal to 8 ohm. The first part of the question is over. The equivalent resistance of the network is 8 ohm. The second part is to find out the voltage VAB and VCD. VAB and VCD. The voltage drop is current multiplied by resistance. To find out VAB and VCD, we should know what is the current flowing in the circuit. So let I be the current in the circuit. Current drawn by the circuit is I. Let I be the current in the circuit. Therefore, VAB is equal to I into RAB. That is resistance between A and B. Similarly, VCD is equal to I into RCD. RCD is the resistance between the point C and D. So VAB, first let us calculate I. I is the total voltage divided by total resistance, or I is the current drawn by the circuit from the battery. So I is equal to battery voltage divided by total resistance in the circuit, that is 8 ohm. This gives us 2 ampere as the current. Now we know all the values. So find out the values of VAB and VCD. VAB is I into RAB, that is 2 into 2. 2 into 2 is 4 volt. Similarly, VCD. VCD is I into RCD. I is 2 and RCD is 4. This will give us 8 volt. So this is the answer for question number A, equivalent resistance of the network, and this is the answer for question number B, that is VAB and VCD. The thing to remember here is, in a complex network, first we need to find out what is the equivalent resistance of each part, like smaller networks. Then we can easily find out what is the equivalent resistance of the whole complex network.